Alright guys, welcome back from the ad break. So I hope you've been really giving it a thought as to what exactly is the difference here. How do you then see it with your eye? When I give you a question, how do you decide which method to use? But for now, let's just look at what a common factor is first, and then later on we're also going to look at what is a trinomial, and then we can then make this comparison that I said you must be thinking about during our ad break. So remember that when you talk about a common factor, this refers to a factor that appears more than once in two or more terms. Now, when we say it appears more than once in two or more terms, it must be in all the terms, right? Because if it appears only on the first two, then you will need to only take a common factor for the first two terms and leave the rest of the terms. But if it appears on all of them, then you can take out a common factor for all of them. Just make sure that if it appears on the first two, you don't put everything else in brackets, but only taking the common factor for the first two terms. Please make sure that you do that. I will show you exactly what I mean by this. Now, the second thing is you always look for a common factor when factorizing an algebraic expression, right? Most of the time, when I did not give you an equal sign, you always start by looking for the common factor, and then you can continue with the rest of the other methods. Now, what does finding a common factor mean? It actually means that you are dividing each term by the highest common factor. The highest common factor of 2a rather, plus 4 will then be 2, right? 2 is a number that is divisible in 2a without leaving a remainder, and 2 is a number that is divisible in 4 without leaving a remainder. So the process of me finding what is written here on the right-hand side, what I will then need to do, I will take the first term, you divide it by the highest common factor. This will just give me a. That's the first term I write inside the bracket. I will take the second term, you divide it by the HCF, which is the highest common factor, and that will give me 2, and that will be the next term that I have there. And then my common factor will be what is outside the bracket. Remember, I said always try to expand in order to see whether you have done the correct thing or not. If you do that, 2 multiplied by a will give us 2a, plus 2 multiplied by 2 will then give us 4. So you can see that this is the same as what we had as a question. Because remember, I said factorizing, is the reverse of expanding. So it means if I expand, it must take me back to what the question was. Let's look at maybe some more complex ones where it's just variables the most. I have m squared minus 3m. The highest common factor here will be m, right? Because it's divisible in m squared and it is also divisible in 3m. How do I then get this thing that is written, the equal sign here? I take each term, divide it by the highest common factor. Let's start with the first one. M squared divided by m will then give me just m. And if I take the 3m divided by m, it will then give me just the 3. Hence, inside the bracket, I have m and I have 3 there, and then the m outside. Again, test whether your answer is correct or not. So m multiplied by m will give me m squared, minus m multiplied by 3 will give me 3m, which is the same as what the question was. So that's how you then test your answer, whether you did the right thing or not. Now also, what if now the common factor is a variable and a coefficient, right? Meaning a variable and a number as a term. So this one, the common factor will be 2a. How do I get my answer again? Remember, the first term, which is 4a squared, you divide it by 2a, and this will give me, the 2 goes in there twice, the a cancels 1a there, and I'm left with 1a, right? And then you can see there I have 2a, and it's not supposed to be just a, it's supposed to be 2a there. And then lastly, if I have 6a divided by 2a, the 2 goes in 3 times, the a cancels the a, and I'm just left with the a. So the actual answer here, guys, is 2a into 2a plus 3, right? So please just make sure that you correct that. Again, you test your answer whether it's correct or not by doing what? Expanding. If I multiply the 2a with the 2a, it will give me 4a squared. I multiply the 2a with the 3, it will give me 6a. And that will therefore be my answer that I initially had as the question. So at all times, guys, it doesn't matter how many terms you are given, right? As long as you took out something as a common fact, each and every term that you have will need to be divided by what you are taking out as a common fact in order to then write whatever that you get inside the brackets. Because if you don't do that, then if you expand, it will not take you back to what the question was initially before you took out the common factor. So please do make sure you do that. Now, remember we said there are 4 ways to factorize to identify a common factor: the difference of squares, trinomial, the sum or difference of cubes, right? Now, if I have a perfect square minus a perfect square, we now call this a difference of 2 squares. So some people normally call it dots, right? They use DOTS to mean difference of 2 squares. At all times, it must be firstly a perfect square with a minus and another perfect square. So a squared is a perfect square, b squared is a perfect square, there is a minus there, therefore this is a difference of 2 squares. Now, why are we calling it a difference of 2 squares? It means that your 2 brackets that you're going to open, they will have both terms that are identical in both the 2 brackets. The only thing that will be different will then be the signs. One will always be a plus, one will always be a minus. It doesn't really matter which side has a plus and which one has a minus, because the brackets will be identical to one another at all times. Remember, difference of 2 squares, perfect square minus another perfect square. And then that's how you gauge yourself with whether it's a difference of 2 squares or not. So, to factorize this, I find the factors of a squared, which is a and a. I find the factors of b squared, which are b and b. So the brackets will have both a and b, a and b. The signs will be different. It will be plus and it will be minus. At times it can be minus, it can be plus there. It doesn't really matter because the brackets are exactly the same. Now, when you are trying to identify a difference of 2 squares, you need to check whether there is a common factor first. That's where you always start. That's why I started with a common factor. Also check if there is a difference of 2 perfect squares, not just any squares, it must be perfect squares, and then take the square root of the perfect squares, right? So here you can see a squared minus 16, is there a common factor? No. So the first step, meaning we don't take out a common factor. We look at the second step. Check if there is a difference of 2 perfect squares. A squared and 16, are they perfect squares? Yes. Is it a difference? Yes. Therefore, it means this is a difference of 2 squares. Lastly, you will take out the square root of each term, which will then be your factors. Now, here, you see, the mistake that one would make will be to use 2 and 2. Why? Because the square root of 16 will be 4, and then a person will assume that because the square root is 4, then I must use 2. But that's not the case. You must use the actual factors of the 16. So the actual answer here will be A and A. For 16, it will be 4 and 4. And then lastly, it will be plus and minus, right? Remember, it can also be minus and plus. It really depends on how you want to then do it. Also, let's look at another example. Remember, start with a common factor. 4a squared minus 16 is a common factor? Yes. Common factor is 4. So I must take out a common factor of 4. If I do that, I will say it's 4a squared divided by 4, which will give me just the a squared. And then I will say 16 divided by 4, which will then give me 4. So what does that mean? My common factor is outside the bracket. I will have a squared minus 4, which are the terms that I got there. Inside the bracket, is it a difference of two perfect squares? Yes, because it's a squared and 4. So I need to find then the factors of a squared, which is a and a, the factors of 4, which is 2 and 2. And then my signs will be plus and a minus. I really prefer always starting with a plus, because then it sets the tone that the next sign definitely needs to be a minus if it's a difference of two squares. So that's just one thing that you can look forward to, because I really personally believe that starting with a positive kind of sets the tone for me, and I will be able to do the others. But remember, it can be minus and plus, it doesn't really matter. Now, this is an interesting one, right? Is it a difference of two squares? We are yet to find out. Firstly, we look at the common factor. But I know that as soon as one sees this plus in the middle, they will automatically think that this is not a difference of two squares because we are adding, right? Because what did I say? I've been saying it must be a difference of two perfect squares. But if you take out your common factor of minus 4 here, you will then see that it will now give us the minus that we need in order for it to qualify as a difference of two squares. So negative 4a squared divided by negative 4 will then give me a squared, which is a positive, and then positive 16 divided by negative 4 will then give me negative 4. And then you can see that in the brackets there will have a squared minus 4. Outside the bracket I will have minus 4. Now, one thing that I should warn you about here, most people, after taking out the common fact, they feel this urge to then multiply the number back. But if you multiply it back, it takes you back to what the question was. So it's like you're just working in reverse and you're not doing anything productive at that time. So please always make sure that you deal with your nerves and you don't just do things because you are used to, if it's brackets, multiply. If it's brackets, multiply. That's not always the case. Just make sure that you do the right thing, please. Now, to factorize the thing that is inside the bracket there, it will therefore be a squared, right, which is a, and then 4, which is 2 and 2. Remember, my personal belief is always start with a plus and then end with a minus. But you can work it out anyhow. Now, let's quickly go to all these questions that we've done thus far. Remember, I said you always need to test whether your factorized version of the answer will give you the original question. Remember, a multiplied by a will be a squared. We use FOIL, remember when we spoke about expanding. A multiplied by b will be minus ab. A multiplied by b will be ab. And then lastly, it will be minus b squared. Then you can see the middle terms will cancel. I will be left with a squared minus b squared. Right? So it does take me back to that particular question that I had. Let's look at this one here quickly. A multiplied by a will also give me a squared. A multiplied by negative 4 will be minus 4a. 4 multiplied by a will be plus 4a. Lastly, 4 multiplied by minus 4 will be negative 16. Let's look at the middle term. Can it be cancelled? Yes. Minus 4a plus 4a is 0, so I will be left with a squared minus 16, which takes us back to what the question was. Let's just test one more. If I multiply out here, firstly you multiply the brackets and then multiply the 4 after. A multiplied by a will give me a squared. A multiplied by minus 2 will be minus 2a plus 2a then minus 4. You can already see that the middle term is going to cancel. If you multiply inside with the 4, then it will give us 4a minus 16. Similarly with this one, it's the very same thing. You multiply inside, I get a squared minus 4, and then you multiply this with the negative 4, it will take you back to that particular question that we had there. So always try to test your answer after factorizing. All right, guys, that's it from me. I hope you are enjoying and you are learning so much from me as much as I'm also enjoying, and I'm really learning from myself as well. But for now, let's just take a quick ad break and we'll be back with some more.